Imagine sitting in the back seat of a taxi in a massive city you have never visited before. You open your Maps app and type in your destination address. In less than a second, the app draws an optimal route for you, avoiding traffic and calculating the time with astonishing accuracy. But have you ever asked yourself, what is happening behind that screen? How did your phone turn millions of streets and intersections into mere numbers and then return them to you as one clear, single answer? The answer hides in a single branch of mathematics called linear algebra. This branch is the hidden engine behind almost everything you touch daily. Search engines, 3D graphics in your favorite games, the artificial intelligence that recommends movies to you, and even the compression of the photos you send to your friends. For the next 15 minutes, we won't be writing complex equations, and we won't drown in dry academic symbols. We will tell a story of numbers that move, tables that change the shape of the world, and maps that guide you from chaos to a solution. By the end of this video, you will look at any two numbers written between parentheses and confidently say, I know what these do. Let's go.
Let's start with the simplest building block in linear algebra, the vector. Forget the word vector for a moment. Imagine asking your friend, where is the cafe? And they reply, walk 500 meters to the northeast. This simple sentence carries two pieces of information, magnitude, which is 500 meters, and direction, which is the northeast. Together, these two pieces of information are called a vector. If you were to write it mathematically, it would look like this: two parentheses with two numbers inside. The first number tells you how many steps do you walk east, and the second number, how many steps do you walk north. But here comes the beautiful surprise. You didn't walk 3 steps to the right and then 4 steps up in a zigzag pattern. You covered the distance in a straight line. How long is this line? Here we call upon our old friend Pythagoras. 3 squared plus 4 squared equals 5 squared. Therefore, the actual distance is 5 steps. This is the length of the vector, or its magnitude. A vector is not just two numbers in parentheses. It is an arrow carrying a complete story of motion. Now, what if you first walked according to a red arrow and then followed a blue arrow? Where would you end up? Simply add the first number to the first number and the second to the second. This is vector addition. You don't need a pen and paper. You need visual imagination. Every vector is a step, and adding vectors is a sequence of steps. That's all. Nothing more.
Now, we move to the second hero of our story, the matrix. Imagine you own a wondrous machine. You feed a picture into it, and it comes out flipped, enlarged, or rotated. A matrix is exactly this machine, but it operates on numbers instead of pictures. It is a grid of numbers arranged in rows and columns. But don't look at it as a boring table. Look at it as a cooking recipe. Every number in the matrix tells you, take a part of the input, multiply it by me, and add me to the output. Let's try it together. If we input the vector 1, 1 into a matrix that says multiply the first number by 2 and the second number by 3, what comes out? The vector 2, 3 comes out. What happened visually? The arrow stretched. It became longer. The matrix didn't change the direction, but it changed the size. If we changed the numbers, we could rotate the arrow, reflect it, or even squash it into a thin line. The matrix is an invisible hand shaping the space around it. And what's even more beautiful, a matrix doesn't just work on one vector. It works on all points at once. Imagine an entire sheet of graph paper. The matrix grabs the whole sheet and folds it, stretches it, or twists it. Every point moves according to the exact same rule. This is the secret to 3D graphics in video games. Millions of points are multiplied by matrices every second to make the movement look smooth to you. Now, let's pose a real problem. You and your friend are at a café. You paid 50 reals for 2 coffees and 1 cake. Your friend paid 40 reals for 1 coffee and 2 cakes. The question is, how much does the coffee cost and how much is the cake? This is an ordinary daily problem, but at its core, it is a system of linear equations, 2 unknowns and 2 equations. Linear algebra gives us an elegant solving tool. We write the 2 equations as a matrix, the unknown vector as a column, and the known numbers as another column. Then we ask, what inverse matrix will return the 2 unknowns to us? Don't worry about the word inverse. Think of it like this. If the original matrix is a lock, the inverse matrix is the key. We put the key into the lock, it opens, and we get x and y directly. In our example, the coffee is 20 reals, and the cake is 10 reals. We solved the puzzle. But what if we had 100 equations and 100 unknowns? This is where computers step in and execute the same logic in fractions of a second. This is exactly what your phone does when it calculates the car route we started the video with.
The beautiful thing is that the principle doesn't change. Whether it's 2 equations or 1,000,000 equations, the idea is the same. A matrix, an unknown vector, and an inverse key. The only difference is the size of the paper we write on. The computer writes on a paper the size of the universe, and we write on a paper the size of a school notebook. But the rule is the rule. Now, let's put all the puzzle pieces together in one scene. Imagine a video game character jumping from a platform. What happens behind the scenes? First, the character's location is a vector, 2 or 3 numbers saying where they stand in space. Second, the jumping motion itself is a velocity vector added to the position vector every single frame of the image. Third, when you rotate the camera or zoom in, what happens is that every point in the scene is multiplied by a transformation matrix. Fourth, if the developer wants to check if the character collides with a wall, they solve a small system of equations. Does the motion vector intersect with the wall's plane?
Notice what happened. Vectors described the motion. Matrices rotated the camera and changed the perspective. And systems of equations detected the collision. 3 concepts, 1 video, 15 minutes of learning, and you now understand the skeleton of an entire gaming industry. This isn't magic. This is linear algebra. Let's summarize at lightning speed. The vector, an arrow carrying magnitude and direction, and it is the simplest way to describe any motion or location. The matrix, a transformation machine that takes a vector and outputs it in a new form, stretching, rotating, or reflecting it. The system of equations, a multivariable puzzle, and the inverse matrix is the key to solving it. 3 concepts, nothing more. And they are the key that opens the doors to artificial intelligence, physics, engineering, and animation. And now, it's your turn. I leave you with a little puzzle. Write your answer in the comments, and I challenge you to explain it to a friend in just 2 words.